For number 9 on the day 4 homework, you have to be a little sneaky. And so we're looking for this value x, and value x is the hypotenuse of the big right triangle, but it's also one of the sides of this non-right triangle that we're going to avoid. So we got to see if we can figure out a way to work with the big triangle and use some of our sine, cosine, and tangent to solve for this. First thing I noticed is that this angle is 20 degrees. Why is that 20 degrees? Because I've got a 70 up there. These two angles are complementary. Okay, so how does that help me? Well, I could solve for this value, which, for lack of a better term, we'll call it h, because we've always called that h in those types of problems. Could I solve for h? I could solve for h, but I'm also going to need this size, or this side, I should say, to be y. And now I've got 3 variables going on. But if I can figure out 2 sides of the big triangle, I can then do some right triangle trig and solve for x. Okay, so let's set up some equations and see if we can get those to come together. I know that the tangent of 20 degrees is equal to h over y. And I know that the tangent of 15 degrees is equal to h over 2 plus y. Now, if I go and solve this whole business there, I will end up with h and y. That still doesn't give me the value of x, but it will allow me to set up a simple triangle trig problem using x. So when everything is said and done, I could say that the tangent of 15 is equal to h over, sorry, not tangent, screwed that up. Let's erase. If I'm solving for x, I would have a sine problem. Sine of 15 degrees is equal to h over x. Okay, so if I can find h, I can then find x. So my goal is to do just that. I'm going to solve for h. So I go through the same process I went through before. So y is equal to h times the tangent of 20. And over here, 2 plus y, don't forget the parentheses there, times the tangent of 15 is equal to h. I did this wrong again. This would be y times the tangent of 20 is equal to h. There we go. Okay, they're both equal to h, so set them equal to each other. Y times the tangent of 20 is equal to 2 plus y in parentheses times the tangent of 15. Y times the tangent of 20 is equal to 2 times the tangent of 15 plus y times the tangent of 15. So distributive property. Take anything with a y and move it to the left side. So tangent of y times the tangent of 20 minus y times the tangent of 15 is equal to 2 times the tangent of 15. Do the reverse of the distributive property and factor out a y. Tangent of 20 minus tangent of 15 equals 2 times the tangent of 15. Remember that this stuff in parentheses is not the tangent of 5. You can't subtract that. So y is equal to, doing a little bit of division here, tangent of 15 divided by tangent of 20 minus the tangent of 15. Okay, what's that value? Well, I got to pick up my calculator here. Being careful again with parentheses. And this y value is 5.6. Okay, it's actually 5.581051555, blah, blah, blah. So I'm going to take this number and I'm going to store it into y on my calculator. Hit the store button, go to alpha y, and store. So now whenever I use the letter, or whenever I hit the key for y, that's going to give me that exact number. That doesn't help me because I need h from our original discussion. So if I come back over here, I notice in this equation, I can figure out h by taking that y value and multiplying it by the tangent of 20. So I'm going to do alpha y times the tangent of 20, and I get h being 2.03 blah, 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 blah. Again, I'm going to store that, and I'll store that into h because it is h. And then, switching to blue, I can solve this problem by plugging that value into h. So let me get this out of the way. So the sine of 15 is equal to 2.03 divided by x. You do the switcheroo, x is equal to 2.03 divided by the sine of 15. Again, I'm using the stored value, not 2.83, so I'm taking h and dividing by the sine of 15, and I get an answer for x, 7.85, or 7.8.